Welcome, cosmic explorers. Today we're embarking on a journey that might just change the course of human history. Imagine a planet out there amidst the vast ocean of stars that's not just similar to Earth, but potentially even better suited for human life. Sounds like science fiction, right? Well, prepare to have your mind blown. Meet Kepler 442b, an exoplanet that's been making waves in the scientific community. Located about 1,206 light-years away in the constellation Lyra, this distant world has captured the imagination of astronomers and dreamers alike. But what makes Kepler 442b so special? Let's dive in. Before we get into the details of Kepler 442b, let's take a moment to understand what exoplanets are and how we find them. Exoplanets are planets that orbit stars other than our Sun. We've come a long way since the first exoplanet discovery in 1992. Today, we know of over 5,000 confirmed exoplanets, with thousands more candidates waiting to be verified. We find these distant worlds using various methods, but the most successful has been the transit method. This involves watching for tiny dips in a star's brightness as a planet passes in front of it. It's like watching a fly pass in front of a distant streetlight. You can't see the fly, but you can detect its presence by the momentary dimming of the light. Now back to our star of the show, Kepler 442b. First off, size matters. Kepler 442b is about 2.3 times the mass of Earth, big enough to hold onto a substantial atmosphere, but not so large that it becomes a gas giant. This super-Earth status gives it some fascinating possibilities. But here's where it gets really exciting. Kepler 442b orbits its star, a K-type orange dwarf, in what we call the Goldilocks zone. Not too hot, not too cold, but just right for liquid water to exist on the surface. And where there's water, there's the potential for life as we know it. Now you might be thinking, but what about its atmosphere, gravity, day length? Great questions. While we can't know for certain without sending a probe there, our model suggests some tantalizing possibilities. Kepler 442b likely has a stronger gravitational pull than Earth, which could lead to a denser atmosphere. This might provide better protection from harmful cosmic radiation, a big plus for potential colonists. The denser air could also create more vibrant sunsets and perhaps even more diverse flying creatures if life has evolved there. Speaking of life, the conditions on Kepler 442b might be even more conducive to biological processes than Earth. Its star is older and more stable than our Sun, potentially providing a longer period of stable conditions for life to evolve and thrive. Let's take a moment to appreciate why stellar stability is so crucial. Our Sun, while generally stable, does have its mood swings. Solar flares and coronal mass ejections can interfere with our technology and, in extreme cases, pose risks to astronauts in space. Kepler 442b's star, being older and less volatile, might provide a more consistently benign environment for life to flourish. However, that's what makes this discovery so exciting. It fuels our drive to develop new technologies, to push the boundaries of what's possible. Concepts like generation ships, suspended animation, or even warp drive, while currently in the realm of science fiction, might one day become reality, driven by our desire to reach worlds like Kepler 442b. While it's tantalizing to think about living on another Earth-like planet, the reality is far more challenging. First up, let's talk about the environment. Kepler 442b's atmosphere might not be suitable for human life. We'd need to terraform the planet or live in sealed habitats with a controlled environment, which is no small feat. Creating a livable atmosphere involves generating breathable air, managing temperature extremes, and protecting against harmful radiation from the planet's star. This requires advanced technology and a tremendous amount of resources. Next, there's the issue of gravity. Kepler 442b has about 2/3 the gravity of Earth. While this might sound like a fun way to jump higher and lift heavier objects, it poses significant long-term health risks. Prolonged exposure to lower gravity can lead to muscle atrophy, bone density loss, and other health complications. We'd need to develop countermeasures, such as specialized exercise regimes, and possibly even artificial gravity solutions. Then there's the challenge of distance. Kepler 442b is over 1,000 light-years away. With current technology, it would take us thousands of years to reach it. This means we'd need to develop faster-than-light travel or generation ships capable of sustaining human life for centuries. Even if we solve the travel issue, the journey itself poses challenges. We'd need to ensure the ship can provide food, water, and medical care for generations, all while maintaining a stable and functional community. Another critical challenge is resource management. We'd need to find or transport all the resources necessary for survival, including water, food, and building materials. This requires advanced resource extraction and recycling technologies. Establishing a self-sustaining colony on Kepler 442b means we must be able to grow food, produce clean water, and recycle waste efficiently. Any failure in these systems could be catastrophic for the colonists. Despite these daunting challenges, the idea of colonizing Kepler 442b remains an exciting possibility. Overcoming these obstacles would require unprecedented innovation and international cooperation, pushing the boundaries of what humanity is capable of. From developing new propulsion technologies to creating sustainable life support systems, the journey to Kepler 442b could revolutionize our approach to space exploration and bring us closer together as a species. If we ever manage to reach and colonize this distant world, it's crucial that we approach it with careful planning and consideration. Here's what we would need to do to ensure a sustainable and prosperous future on Kepler 4422b. First, let's talk about environmental protection. The pristine environment of Kepler 442b must be preserved to avoid the mistakes we've made on Earth. This means strict regulations on pollution, waste management, and resource extraction. We would need advanced recycling technologies to minimize waste and prevent contamination of the planet's natural ecosystems. Utilizing renewable energy sources like solar, wind, and possibly even geothermal energy would be essential to minimize our carbon footprint. Next, we need to establish sustainable agriculture and food production systems. Growing food in an alien environment presents unique challenges, but with hydroponics, vertical farming, and other innovative agricultural techniques, we can create self-sustaining food supplies. These methods use less water and land than traditional farming, making them ideal for a new colony. We'd also need to ensure the genetic diversity of our crops to prevent diseases and pests from devastating our food supply. Water management is another critical aspect. We would need to identify and protect sources of fresh water, ensuring they are not overexploited or polluted. Advanced water purification and desalination systems would be necessary to provide clean drinking water for the colony. Efficient use and recycling of water would help us maintain a stable water supply. Now let's address economic sustainability. To prevent economic problems, we would need a well-thought-out economic plan that promotes fairness, innovation, and resilience. A diverse economy that includes agriculture, manufacturing, research, and technology development would help create jobs and promote stability. Encouraging entrepreneurship and small businesses would foster innovation and adaptability within the colony. Education and training would be vital for the success of the colony. We would need to invest in educational institutions and vocational training programs to ensure that colonists have the skills needed to thrive in their new environment. This would include everything from scientific research and engineering to farming and healthcare. Healthcare infrastructure would be essential to maintain the well-being of the colonists. We would need advanced medical facilities, trained professionals, and access to medical supplies and technology. Preventive care, regular health checkups, and a focus on mental health would help create a healthy and resilient community. Social and political stability is crucial for a thriving colony. Establishing a fair and transparent governance system that allows for representation and participation of all colonists would help maintain peace and cooperation. Promoting cultural and recreational activities would enhance the quality of life and strengthen the social fabric of the community. Finally, we must be prepared to adapt and learn. Living on Kepler 442b would present unforeseen challenges, and our ability to respond to these challenges with creativity and flexibility would determine our success. Continuous monitoring of the environment, economy, and social systems would help us make informed decisions and adjust our strategies as needed. Colonizing Kepler 442b is an ambitious and exciting prospect, but it requires careful planning and a commitment to sustainability and equity. By learning from our experiences on Earth and leveraging advanced technologies, we can create a thriving and harmonious society on this distant world. So what do you think about the potential of colonizing Kepler 442b? How can we ensure a sustainable and prosperous future for humanity on another planet? Let us know in the comments below. Don't forget to subscribe and hit the notification bell to stay updated on all our cosmic adventures. Thanks for watching and stay curious.